On the first three terms in this binomial expansion in ascending powers of x. So we're given this binomial expansion for rational coefficients, n rational, which is what we've got here. We've got to make it so it's 1 plus something first, though. So what we can do is take a 4 plus 3x to the 3 over 2 and factorize out the 4. So 4 times 1 plus 3 over 4x. Now this is all to the power of 3 over 2, but instead you can just raise each one to the power of 3 over 2, which gives us 8, because it's the square root of 4 and then cubed, so 8, 1 plus. Right, now we're ready to apply the formula. I'll keep this 8 in there and deal with the rest of it. So it will be 1 plus n. Remember, n is actually 3 over 2, and my x is 3 over 4x. So just replace all my x's by 3 over 4x and all my n's by 3 over 2. So 3 over 2 times 3 over 4x. We're only asked for the first three terms, so just one more. Then 3 over 2 times 1, n minus 1. So that's going to be 3 over 2 minus 1, or a half. All over 2 factorial, which is 2 in this case. Then 3 over 4x all squared. Make sure you put that in a bracket. And there's some other terms, but we're only interested in these ones. So I'm going to get 8 plus 8 times 9 over 8x. Actually, those 8s are going to cancel out. Plus 8 times 3 over 8 times 9 over 16x squared. These 8s cancel out. And that leaves me my final answer, 8 plus 9x plus 27 over 16x squared. Part B asks us for the, Part B asks us for the range of values of x, which expansion is valid. Well, we're told that this has to be true. But for us, remember, it was x was replaced by 3 over 4x. So we require that the modulus of 3 over 4x is less than 1. And therefore, the modulus of x is times 3 by 4 divided through by 3. Modulus of x is less than 4 over 3. If you prefer, you can write it as minus 4 over 3, less than x, less than 4 over 3. Finally, we're told in the expansion of this function that we've dealt with already, times by 1 plus ax all squared, the coefficient of x squared is 107 over 16. We're asked to determine the possible values of a. Okay, so what we can take is this bit here as the expansion that we found. And then 1 plus ax squared, well, that's 1 plus ax times 1 plus ax. I'm going to get in another bracket 1 plus 2ax plus a squared x squared. And I'm interested in all the different ways that I can get a coefficient of x squared. I note I don't need any more terms here. I don't need the x cubed term, and that's why we're only asked to find the first three. This is enough. Well, I can get a term by doing 8 times a squared x squared. That'll give me 8a squared x squared. The coefficient is then just 8a squared. I could get another term by timesing the x's. That'll give me 18a. And then finally, another one by doing 27 over 16x squared times 1, which gives me 27 over 16 as my coefficient. And that is going to equal this coefficient 107 over 16. Looks like we've got ourselves a quadratic in A. So I'm going to minus the 107 over 16. That actually gives me minus 80 over 16, which simplifies to minus 5. It's up to you at this point. You can put it in your calculator or you can try and factorize it. Like, it looks awkward to factorize because of the 8, but actually the 5 means it has to be plus 5 and minus 1, or the other way around if it's going to factorize. I tried 8 and 8a and a to start with. I quickly saw that wasn't going to work. But if you go with 4a and 2a, put a 5 there to give 20a, a 2 there, sorry, not a 2, a 1 there to give 2a, make that a plus and that a minus, it checks out. Set it equal to 0. So a is either going to equal a quarter or minus 5/2. Nice one.